Optimisation and calculus curves. In this video we're going to look at the topic of optimisation and calculus curves. This is a difficult topic that is often asked in the more complex questions on an IB exam. First thing, we're going to look at a curve and discuss the relationship between f of x, f dash of x and f double dash of x at critical points along the graph. I've drawn on 5 critical points, A, -4, B, 1 and C, and at each of these points we will discuss what is happening to the function, what is happening to the first derivative at that point on the function, and what is happening at the second derivative at that point on the function. So first, let's take the point A. So we want to discuss what is happening at f of A. F of A is actually the y value at that point on the function. And as A lies on the x-axis, f of A is actually equal to 0. So then f dash of A. Well, at that point, if you draw a tangent at A, you can clearly see that that tangent has a positive value. So the gradient at A is equal to a positive number. We don't know what that positive number is, but it is definitely positive. Now let's look at the second derivative at A, so f double dash at A. If you look at the graph, you can see that the second derivative is part of an upside down concavity. So the second derivative at A is negative. Now let's take our second point, f4. If you move to f4, you can clearly see that f4, we don't know the exact value, but it is definitely positive. If you look at f dash 4, well, if you draw your tangent line, the tangent line there is clearly horizontal, so it has a value of 0. Again, at f double dash of 4, it is still part of a negative concavity, so f double dash 4 will be negative. Now let's move along to our third point, f of b. F of b, if you move to the point on the graph, it is below the x-axis, so f of b is negative. If you move to f dash of b, if you draw in your tangent line at b, you can clearly see that the gradient at b is negative. F double dash of b, well, b is at a point where the concavity changes from negative to positive. So at B, the concavity is equal to 0. It is the changing point from a negative concavity to a positive concavity. Now if we move along to our fourth point, 1, so F1, well, it is clearly below the x-axis, so the value of f1 is negative. F dash of 1, well, if you draw your tangent line again, it is clearly horizontal, so we have a gradient equal to 0. It is at a minimum point. And if you take f double dash of 1, it is part of a positive concavity. So f double dash is positive. And moving along to our final point, f of c is on the x-axis, so it's fc is equal to 0. F dash of c, if you draw in your tangent line, it is clearly positive. And f double dash of c, it is still part of a positive concavity, so f double dash of c is positive. Hopefully now you'll be able to describe the difference between f of x, f dash of x, and f double dash of x as you go around the curve f of x. Optimization problems might involve area, volume, where you have to find either the local maximum or the local minimum. Now you find the local maximum or minimum by putting f dash of x equal to 0. You can decide whether it is a maximum or minimum by using f double dash of x. If it is less than 0, you have a maximum. If f double dash of x is greater than 0, it is a minimum at f of x. This is a typical IB question. A small cuboid box has a rectangular base of length 3x centimeters and width x centimeters, where x is greater than 0. The height is y centimeters, where y is greater than 0. The sum of the length, width and height is 12 centimeters. Write down an expression for y in terms of x. So we know that 3x plus x plus y is equal to 12. Therefore, 4x plus y equals 12. Therefore, y is equal to 12 minus 4x. 1b. The volume of the box is v cubic centimeters. Find an expression for v in terms of x. So 1b. The volume is equal to 3x times x times 12 minus 4x. Therefore, v is equal to 36x squared minus 12x cubed. 1c. Find dv over dx. So dv over dx is equal to 2 times 36, which is 72x, minus 3 times 12 is 36x squared. 1d. Find the value of x for which v is a maximum. So 1d. For a maximum, dv over dx is equal to 0. Therefore, 72x minus 36x squared is equal to 0. Therefore, 36x brackets 2 minus x is equal to 0. Therefore, x equals 0 or x equals 2. X equals 0 is impossible, therefore x must equal 2. 1e. Justify your answer. To prove that x equals 2 is a maximum, we can find the second derivative. So v double dash is equal to minus 72x. Therefore, v double dash 2 is equal to minus 72 times 2, which is minus 144. Therefore, because v double dash is less than 0, therefore maximum. 1f, find the maximum volume. Well, that occurs at v2, which is equal to 48. So the maximum volume is equal to 48 centimeters cubed. This is another good example of an IB question. Let f of x equal minus 0.5 x to the power of 4 plus 3x squared plus 2x. The following diagram shows part of the graph of f. There are x-intercepts at x equals 0 and at x equals p. There is a maximum at A, where x equals A, and a point of inflection at B, where x equals B. A. Find the value of P. We want minus 0.5 x to the power of 4 plus 3x squared plus 2x to equal 0. In order to solve this, use your GDC. And when you use your GDC, x equals 2.73. 2b. Write down the coordinates of A. A is a maximum, so we need to find the derivative of f of x. So f dash x is equal to 4 times minus 0.5 is minus 2x to the 3 plus 3 times 2 is 6x. 2x becomes 2. At A, we know the derivative is equal to 0. Therefore, minus 2x cubed plus 6x plus 2 is equal to 0. Use your GDC to solve, and you get that x is equal to 1.88. To find the y coordinate, put 1.88 into f of x, and you get y is equal to 8.12. So the coordinates of A are 1.88, 8.12. 2c, write the rate of change of f at A. Well, the rate of change is equal to 0 because it is a maximum, and at a maximum the rate of change is equal to 0. 2d, find the coordinates of B. We are told that B is a point of inflection. That means that f double dash B is equal to 0. Therefore, minus 6x squared plus 6 is equal to 0. So minus 6x squared is equal to minus 6. So x squared is equal to 1. So x is equal to 1 or minus 1. But in our case, it must be x equals 1. And if you substitute x is 1 into f of x, you get y is equal to 4.5. 2e. Find the rate of change at B. Well, the rate of change is f dash. At B is 1. So that is equal to minus 2, 1 cubed, plus 6 times 1 plus 2, which is equal to 6. So the rate of change at B is 6. Let R be the region enclosed between the graph f of x and the lines x equals A and x equals B. Find the area under the curve. So 2f, we want the integral between x equals 1 and x equals 1.88 of minus 0.5 x to the power of 4 plus 3x squared plus 2x dx. If you do that on your GDC, you will get the answer 5.93 to 3 significant figures.